Hello friends, today in this video I will talk about the review of probability theory and random processes. So let's start. So these are the topics that I will discuss on this video. So at first let us know what is a random experiment. A random experiment is the process to observe the event having an uncertain outcome. When we toss a coin, the outcome is uncertain and hence it can be termed as a random experiment. Next is sample space. The set of all the outcomes of a random experiment is known as sample space. The sample space is usually denoted by the Greek letter omega. Here we can see this is the symbol of the sample space. So now, for example, while tossing a coin, the sample space will include head and tail. So next is the sample point. Sample point is one of the possible outcomes of the experiment. A sample point is indicated by its lower case version omega, which is this one. Here you can see. In the above experiment, or in the above example, the head or tail can be called as the sample points. So let's move on to the next topic, events. So an experiment can be called as a process or a happening which will lead to different outcomes. Different outcomes of an experiment are known as events, or it is the subset of the sample space. For example, getting a head while tossing a coin is an event. Events can be classified in various ways depending on different characteristics. Like the first one is the sure event. The sure event is an event that has a 100% probability of occurrence. For example, getting a head or tail while tossing a coin is a sure event. Impossible event. If the probability of an event is zero, then it will be known as an impossible event. For example, getting a 7 while throwing a die is an impossible event. Next is the independent event. Independent events are those events where the occurrence of one event will not affect the probability of occurrence of the other event. For example, if we toss a coin twice, then the outcomes are independent of each other. Next is the dependent event. Dependent events are those where occurrence of one event will affect the other event. For example, if there are 3 red and 2 green balls in a bag, and one green ball has been taken out, then the probability of getting a green ball in the next attempt will get affected. So let's move on to the next topic, which is probability of an event. Probability is the measure of how likely an event is, and an event is one or more outcomes of an experiment. Probability formula is the ratio of number of favorable outcomes to the total number of possible outcomes. So if there are n exhaustive equally likely elementary events in a trial and m of them are favorable to an event A, then probability of A will be equal to m by n, which will be equal to possible outcomes favoring event A by total number of possible outcomes. So let's move on to the next topic, which is axioms of probability. So there are 3 axioms of probability. The first axioms of probability is that the probability of an event is a non-negative real number. That is, probability of A is greater than or equal to 0 for all A, which is subset of the sample space S. So this means that the smallest that a probability can ever be is 0 and that it cannot be infinite. One thing to note that this axiom says nothing about how large the probability of an event can be. So the second axiom of probability is that the probability of the entire sample space is 1. So that is probability of S equal to 1. So implicit in this axiom is the notion that the sample space is everything possible for our probability experiment and that there are no events outside of the sample space. So the third axiom of the probability deals with the mutually exclusive event. If the event A and B are mutually exclusive, meaning that they have an empty intersection. That is, if A intersection B equal to phi, then probability of A union B will be equal to probability of A plus probability of B. So let's move on to the next topic, which is implications of axioms of probability. Consider a sample space S is equal to S1, S2, S3 up to Sn. So now let Pi equal to probability of Si, where Si is an element from on the sample space S. So the first implications of axioms of probability is that P of I is greater than or equal to 0. So the next implication is that the summation of P of I is equal to 1 for all I Si belongs to sample space S. So the third implication is that probability of any event A will be equal to summation of Pi for all I Si belongs to the event A, and the event A is the subset of the sample space S. So let's move on to the next topic, which is conditional probability. It measures the probability of an event if another event has already occurred. In other words, we can say that conditional probability of an event is the probability of an event that given that another event has already taken place before it. The probability of outcome B given an occurrence of outcome A is called conditional probability of B given A is defined as probability of B by A is equal to probability of A intersection B by probability of A. Let's move on to the next topic, which is random variables. So the random variables are important concept of probability theory. It can be said as the very basic concept of probability theory. Random variables are those values whose values are dependent on the outcomes of some random experiment. Random variables can be categorized as discrete and continuous. So discrete random variables. Discrete random variables are those who take discrete values, that is countable values such as 0, 1, 2, 3, etc. Some examples of discrete random variable are number of kings coming while choosing n cards from deck of 52 cards. So next is the continuous random variable. A continuous random variable is one which can take up infinite random variables. For example, height of student in a class can have infinite number of values, and hence it will be called continuous random variable. So next is the constructing a probability distribution. A probability distribution is a pictorial representation of the probability of different values of random variables. For example, out of the 3 bulbs, the probability distribution of random variable of number of defective bulbs can be given as shown. Here you can see this is how we construct a probability distribution. So here, where the probability for different values of random variable x has already been given. In general, to construct a probability distribution for random variable x, the probability for different values of x should be calculated and written in a tabular format or in a chart. So next is the function of a random variable. If x is a random variable and y equal to f of x, that is y is a function of x, and then y is also a random variable, the probability distribution of y equal to f of x can be found using the given techniques. The first is the distribution function technique. The second is change of variable technique. The third is 2-to-1 transformation. Let's move on to the next topic, which is distribution functions for random variables. The cumulative distribution function, or briefly the distribution function for random variable x, is defined by f of x equal to probability of capital X less than equal to small x, where the small x is any real number, that is, it lies from infinity to minus infinity. The distribution function fx has the following properties. The first property is that f of x is a non-decreasing, that is f of x is less than f of y if x is less than equal to y. So then the second property is limit x tends to infinity, f of x is equal to 0, and limit x tends to minus infinity, f of x is equal to 1. So the third property is that the f of x is continuous from the right, that is limit it tends to 0 positive, f of each plus x is equal to f of x for all x. So now the question arises, why do we need to find probability? So probability is the chance that something might happen. When you calculate the probability of an event, you look at chances of getting what you want versus all the possible things that can happen. The probability of an event that you know for sure will happen is 100% or 1, while the probability of an event that will never happen is 0% or just plain 0. So from this we get some idea. So why do we need probability? So next question is, why do we need to find distribution function for random variables? So it is difficult to write probability of every single event, that is every possible point in the real line, as we have to define probability of every possible interval. So the next question is what is the probability of getting 53 Mondays in a leap year? To solve this, so first we need to know how much days a year has. So we know that usually it has 365 days, but if it is a leap year, then it will have 366 days. So a year has usually 52 weeks, and hence there will be 52 Sundays for sure. So if there is 52 weeks, so which is equal to 52 into 7, then which is equal to 364 days. So in a leap year there will be 2 extra days. So in a leap year there will be 2 extra days. So the 2 days can be Sunday, Monday, Monday, Tuesday, or Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, or Saturday, Sunday. So out of total 7 outcomes, the favorable outcomes are 2. So hence the probability of getting 53 days will be equal to 2 by 7. So that's all for the video, guys. So I hope you have got some idea from this video. So thank you and have a nice day.